So how do we catch exceptions? Well, we can trap catch exceptions before they report an error. And we do this with a try except statement. So let's say we have a program that lets the user enter two numbers and then divides one by the other. So I'm going to make a new program. And we're going to do this. We'll say x is equal to, and we're just going to do a standard input. And we'll say y is equal to the float input. Please enter second number. And then we're just going to print x divided by y. Let me fix this and run it again. And so if I put, say, 10 and then put 0, we get a zero division error. And this isn't a great user experience, especially if we wanted to put this in maybe some kind of a loop. So maybe we'll put it in a do another loop. And, you know, ideally this would run this way, right? Let's try this again. Five, 7, do another yes. 9, 3, do the other one yes. And then you do 9, 0, and it just stops. What you would really like to do is have it just keep going on. So how can we deal with that? Well, what we can do is we can put it in a try and except block, and we'll print error, try again. So now if I put 5 and 7, it does it. I try to do another, put 9 and 0, it displays my error message. So it catches an exception. However, this is very generic. It catches every exception. Maybe what I want to do is catch this specific exception. So I can copy that. And by doing it this way, I know that this will be a zero division. And what that allows me to do is say the second number can't be 0. And now if I start running this program, it works. And if I put something that's division by 0, I get a very specific error message because I know I'm catching a 0 exception. Another one could be like this. So I'm going to make another program here. And this one, I'm going to say num str is equal to input. Please enter a number. Notice I'm inputting a string, and then I am going to say num is equal to the float of that string I got in. And here I'm going to so I'm going to enter a number. And let's say I put in 5. Well, 5 is clearly not a number. If I do that, I get a value error this time. Could not convert string to float. So the question is, what error do we need to catch? Well, conveniently, it's right there. So now I can wrap this in a try catch. Indent this in. I don't want the zero division error. I want this one. So we can just copy and paste that in here. Try except. Okay, so now we have a try except block. We're catching the value error, and now if I run this, if I put 5, must be a number. So the general workflow for catching exceptions is this: write some code, test it, trying to find inputs that cause exceptions, note the exception it causes, and then wrap the code in a try block, add an except block for the error message that you get. Some common exceptions are the arithmetic error, overflow error, and there's actually a hierarchy to our exceptions. Arithmetic error is a special case of exception. Overflow error is a special case of arithmetic error. Zero division error is a special case of arithmetic error. So you can, if you catch an arithmetic error, it'll catch either an overflow or a zero division error. If you catch exception, it'll catch all exceptions. We also have IO errors, index errors, syntax errors, tab errors. So there's a lot of different errors that you can catch, and they're in a hierarchy. If you catch the higher level error, it'll catch all of the child errors that are related to it. So we can so you can go to the Python documentation on exceptions, and it shows you the hierarchy. So we see here's the base exception class, here's the arithmetic errors. There's actually 3 different exceptions: floating point error, overflow error, zero division error. And so, for example, if I catch an OS error, it will catch all of these. If any of these child errors occur, it'll trigger the OS error. So often what we're doing is picking the right level of error that we want. So that's the fundamentals of catching an error. Thank you very much.